Yeah, definitely.
This team was working with Lutron, looking for opportunities for using more energy efficient lighting here at the university.
All right, can everybody hear me without the mic? We all good? People in the back? Okay, very good. So before we start, I just have to say that it's really been a pleasure to work with this team. It feels like just yesterday we were performing, doing a little bit of norming, and now we're performing for you. So my name is Daniel Jason Midsley, and I'm a business management major.
I'm TJ Fallahoo, and I study bioengineering.
I'm Anleen, I'm a finance major.
My name is Laura Asher, I study electrical engineering.
Stephen Barbagallo, materials science.
And we are Team CarbonBLACK. So what we like to do first is take you back to middle school for a second. So when you were a kid, your parents loved you a lot, and they probably gave you the talk, which went something like this. They said, Mike, look, you're a great kid, you're very talented, we love you a lot. We just want to make sure that you're doing one thing for us, and that is turning off the lights when you're not using them, because otherwise it wastes a lot of time, because we got to yell at you and get in that whole match, you know what I mean? It also wastes a lot of energy, and it wastes a lot of money. So stop for a second, because we want you to take the visualization just a little bit further. So imagine that your parents are reacting to some of the information that we're going to share with you today about Van Munching Hall. And imagine that Van Munching Hall is their home. So, thank you. So, we found that 43% of the time, lights are on in classrooms when no students are in the space. We found that 54% of the time, lights are on in computer labs when nobody is drafting a presentation or working on an essay. We found that 66% of the time, lights are on in stairwells when nobody's climbing the steps. And we found that 81% of the time, lights are on in office hallways when nobody's walking from room to room. So if you go back to that visualization with your parents, they're probably cringing right now, right? And that's the exact same reaction that we had when we realized that our home at Van Munching Hall was this inefficient.
Okay, so as we can see, there's a lot of energy waste in Van Munching Hall. And what we want to find is the sources of this waste. And we found three main sources of energy waste in Van Munching Hall. These include illuminated, unoccupied spaces. So the lights are on and no one's there. Overlit spaces where the lights are just too bright when they don't need to be. And outdated lighting technology. And our client, Lutron Electronics, has solutions that could solve all of these problems. Now, Lutron Electronics is a manufacturer and designer of energy-saving lighting solutions. And using their solution, we can address each and every one of these problems. Now, as for the unoccupied spaces, we can have sensors to turn the lights off when no one's there and turn them on when someone walks in. As for overlit spaces, light controls can be used to reduce the intensity of the light to save a lot of energy in the long run. As for the outdated light technology, they can be retrofitted with dimmable fluorescent bulbs, which are not only a lot more energy efficient, but customizable to individual spaces. Lutron also offers more complex systems, such as Quantum, which offers complete light control of a space using all of these components that I just described, and even more. Quantum could also be upgraded with Hyperion, which is a shading system. Now, Hyperion works by maximizing the amount of natural light in an indoor setting. Now, given all these solutions, our objective was to identify opportunities for lighting control in order to increase the energy savings and carbon reduction in Van Munching Hall.
So how do we reach these solutions? Our first step was to assess Van Munching Hall, and we worked with Lutron's partners, Hunt Consulting, to conduct a lighting inventory of 4 spaces: classrooms, computer labs, stairwells, and hallways. and we took down the type, the number of, and the wattages of the lighting fixtures to get a better understanding of the energy usage in the building. Then we installed data loggers across these spaces, and we kept them up for about 10 days to gather that useful occupancy and lighting information.
So our next step was to process the data that we collected and relate it back to Lutron's 4 systems of interest that we touched on earlier. So to do this, we crunched some numbers and came up with a scorecard that assesses each of the 4 systems on 4 characteristics: energy savings, carbon reduction, return on investment, and aesthetics. So for example, the occupancy sensor scores very highly in return on investment because it requires minimal labor and capital to install. In contrast, it adds little visual value to a room because it operates when the room is vacant. So we were able to apply this method to come up with different combinations of solutions to recommend and tailor for different tenants.
So with this scorecard in mind, we moved on to make some recommendations. So we have 2 sets of recommendations. The first set of recommendations is for now, while the second is for farther down the road. Now, if we look at the now recommendations, we see 2 things: install occupancy sensors and install dimmable ballast immediately. We're going to talk about some of the value that these bring to the University of Maryland and Van Munching Hall, quantifiably in numbers. But one of the big things is they both have a very short payback period, which is something that's very valuable when making these purchases and investments. The second thing that we suggest and recommend for the next semester is to apply this methodology. So this project will actually continue. And we believe there are other buildings on Maryland's campus that offer even bigger opportunities for savings and improvement. And we're going to pinpoint them and suggest them for the next team moving forward. In terms of the later recommendations, so TJ spoke about quantum and Hyperion. Both of these systems can provide immense value to a building or an organization if used properly. However, our research found that on Maryland's campus, there exist 2 total light management systems, one actually being the quantum system. And as of today, neither of those systems are being used to their maximum potential. One building you all may well be familiar with is 251 North, a diner on North Campus. This building was designed and built to be one of the most energy efficient buildings on campus. I have no doubt that quantum was a big part of that. However, today, 251 North ranks as one of the least energy efficient buildings on campus because in many aspects, the system has been neglected and thrown to the wayside. In many cases, this is because it's a complex system and the training is just not there. It takes a lot to deal with. So we recommend that if this system is to be installed again at Maryland's campus, in a building such as Van Munching Hall, that it be done with the caveat of a training system so that it can be used to maximize the investment of both parties involved. Now, what's the impact of these recommendations? So, in terms of climate neutrality is something that the University of Maryland has committed itself to. In fact, UMD has decided that by the year 2050, they will be carbon neutral, meaning that for every pound of carbon that is created by the University of Maryland, a pound will be taken out of the atmosphere. So currently, Van Munching Hall, the electricity used by the building generates 5 million pounds of CO2. Now, to put some perspective to that number, that's the equivalent of 400 cars annually. If we could take that 5 million out, that would be the same as 25% of Maryland's faculty just carpooling every day. Now, we believe we can pull that number down by 400,000 just by installing occupancy sensors. That's a 7.6% reduction in electricity emissions in just this building alone. In terms of the monetary savings, these recommendations make a lot of sense because they have short payback periods, as I mentioned. So we believe that occupancy sensors and dimmable ballast will pay for themselves in less than 16 months. Additionally, the quantification we did was using those sensors. We found that on average, a classroom wastes $1,600 in electricity every year. Considering that there's 28 classrooms in Van Munching Hall, we believe that this simple recommendation could save the University of Maryland and the business school $44,000 every year. With that in mind, I'd like to bring you guys back to DJ's story at the beginning. So, when your parents gave you that talk when you were a kid, I'd like you to look back at your parents and say, "Hey Mom, it's okay. I can save you $44,000. With that being said, I'd like to make some acknowledgments. Bill Marushak and Joel Shumsky helped us immensely. They're our project champions and partners at Lutron. We'd like to also thank Dr. Michael Ohadi and the Quality Guild and the Quest program. They were immensely useful to us in making sure we stayed on track on this project. And finally, we'd like to thank Anthony DiCarlo and Sean Taylor of Lutron for helping us with some financials along the way. With that, I'd like to open the floor for questions. Eric?
So I know there's going to be a lot of initial costs to install the system. How long will it take back from the time at school to get their money back?
So the question was, there's cost associated with installation. How long will it take for the school to make its money back in savings? About a year and a half for the recommendations we are suggesting at this time. Mason?
Great presentation, guys. I loved it. So my question is, so you guys mentioned there's some other buildings you guys are looking at on campus. Where is the next opportunity?
Right, so the way we identified opportunities was based on A, EUI, which is Energy Utilization Index, as well as B, some of the features of the architecture of a building that would make a system such as Quantum or Hyperion a good fit. So one building we're very interested in is the Epley Recreational Center for utilization with the Hyperion shading system. The reason for this is the Epley Rec Center, or the ERC as we sometimes call it, for those of you unfamiliar, consists of a lot of window surface areas. So we haven't run the numbers, but a very large quantity of the wall surface is windows. So there's a lot of solar flux hitting those windows every day that could be used in lieu of the lights that they power.
Who should be trained to operate your quantum systems? Who would be the people that are receiving that training?
Right, so right now, facilities, so to repeat the question, who would be receiving the training for these systems? So right now, facilities management is in charge of most of the buildings. There's another light system that's installed in UMERC, or the University of Maryland Energy Research Center, and I actually believe that that is run by the people who use the building, so the professors and the researchers. So I think it would depend really on where the system was installed. For instance, it doesn't make sense to have this putting facilities into buildings that they don't need to be into if you can have somebody within that organization controlling the system.
Was any consideration given to lighting besides the dimmable ballasts, such as LEDs, which might use less electricity? And was any consideration given to the longevity of the actual bulbs being used? Because if you use bulbs that last longer, there's less cost in labor in changing them and such.
Great question. So the question was, did we give any consideration to what types of lights are being used and the longevity of newer lights versus older lights? There was some consideration made, but most of our recommendations were based on making as little changes to the lighting infrastructure as possible right now. These systems are modular, so they can be added and built upon as time goes and the university decides to either make a larger or smaller investment in the program. So we wanted to kind of make an entry point right now, and that, prevents us from taking out all of the lights and putting them back up all at once.
Was any thought given to, the university it's a unique space, but was any thought given to the feelings of safety that students might feel in dark hallways and stairwells?
Yeah, so absolutely a great question. The question was, universities are very unique spaces considering we have students here. This isn't like a work or an office environment. This is for many students their home. So if you look back at that 81% number that DJ mentioned in terms of stairwells, there's some legal parameters that go into spaces such as that. So for instance, you're required to have 1 foot candle lighting a stairwell at any point in time. It's a building code, right? But 1 foot candle can very often feel like a dark parking lot at night. So when you actually combine these two systems together, the dimmable ballast and the occupancy sensors, you can make sure that the light is right when it needs to be, but not when it doesn't. So a lot of that hallway is turning the lights on when someone's there, and then dropping them down to where they legally need to be when no one's there.
Thank you very much.
Project of the year. So turning back.